Okay, today we're going to be talking about proportions. So again, two vocabulary words that we should probably look at before we get started. And the first one, of course, is proportion. So what a proportion is, it's an equation, which means there has to be an equal sign. And that equation is stating or saying that two ratios are equivalent, which means they're equal. Remember, our ratios are two things that are comparing each other, or two things that are being compared to each other. So if I say 6/8 is equal to 9/12, that is one ratio being equal to another ratio, which means it is a proportion. Some people say, oh, it's one fraction equal to another fraction. Well, that's one way to look at it, but ratios aren't fractions. They are two things that are being actually compared to each other. Now, if I give you 5/2, 5/2, and I say that is not equal to 15/8, well, those are two ratios, but they are definitely not a proportion. They're not equal to each other. But now let's go ahead and look at cross products. Cross, like diagonals. Products, meaning the answer to a multiplication problem, we're going to be multiplying our diagonals. Now what this says is in a proportion, if they really are equal to each other, the product, when I multiply the numerator on one side with the denominator on the other, they will be equal. So let's look at this one that I gave you up above. I already told you it was a proportion, but let's see why. If I go ahead and do 9 times 8, that's a cross product, and again, doesn't matter which diagonal you do first, that's 72. When I multiply the other diagonal, 6 times 12, well, that is also 72. So if those cross products are equal, that says for sure it's a proportion. Now look at this other one. If I do 5 times 8, well, that gives me 40. When I do the other diagonal, 15 times 2, well, that's 30. And 40 is definitely not equal to 30. So let's look at some examples that we're going to be working with today. First thing I'm asking you to do is just look at these two ratios and tell me, do you think they really are proportional? Yes or no? So I'm telling you in these steps, there's two ways to look at it. You can use cross products, meaning you can go ahead and multiply those diagonals. And I always say, if the numbers are easy to multiply mentally, do it. Use that part. So let's go ahead and look at this one. I can multiply by 5s. I love multiplying by 5s. That's not hard for me. So I'm going to go ahead and multiply this diagonal. 6 times 5, well, that's 30. And then 5 times 21, well, that's 105. That is definitely not equal to each other. So now, step 2 says, if they are equal, well then yes, they're proportional. If they are not equal, then they are definitely not proportional. So I'm hoping you will be able to tell me no on this one. They are not proportional. Now if I go ahead and look at B, again, I'm multiplying 10s. Okay, I can do that. And 25s on the other. Oh, I can do that. Let's go ahead and multiply. That's going to be easy for me. So 10 times 15, well, add that 0. That's 150. And now 6 times 25. Remember, 25 is like quarters. So if I have 6 quarters, how much do I have? Well, that's $1.50. So 150 and 150, definitely the same, which means yes, these are proportional. So now let's look at that next one, C. Oh, no way. I am not going to want to multiply 42 and 16 and 14 and 36. Would you want to go ahead and multiply these cross products? Would you want to multiply those numbers? I know mentally, no, I wouldn't want to. I could do it on a piece of paper, but if I want to go quickly, no. Well, that's when I give you this other step in step 1. If the numbers are too big to multiply mentally, then what I could do is I'm just going to reduce each ratio to as small as it can possibly be. So I'm going to reduce them. So let's go ahead and look at that first one. That first one is 14 and 42. Well, I know 7 goes into 14 evenly, and 7 goes into 42 evenly. So let's go ahead and see what we get. 14 and 7 divided by 14, well, that gives me 2. 7 goes into 42, well, that is 6. Can I reduce it anymore? I sure can. I can reduce that by 2 again. And when I do, I get 1/3, 1/3. So my first ratio reduces to 1/3. What about that next one? 16 and 36? Well, I know 4 can go into each one evenly. So let's go ahead and reduce that one. 4 goes into 16 4 times. 4 goes into 36 9 times. Can I reduce it anymore? No. So now, what about this? Is 1/3 equal to 4/9? No, not even close. They are not the same. If it came out to be the same, they'd be equal, but these are not equal, which means those two original ratios are not proportional. So let's go ahead and look at this next kind of problem. And that is telling you these two things are equal. These have equal signs between them, so they are equivalent. So I know that when I actually look at their diagonals, they also have to be equal. So if I give you a variable that you have to solve for in a proportion, then I'm going to use my cross products to create an equation. So let's look at those cross products. And again, it does not matter which diagonal you do first. I know I personally usually pick the one where the variable is. So I'm going to do this one first. M times 25. Well, M times 25 is just 25M. Now I'll put the equal sign between because I know they are proportional. And now I'm going to go ahead and do that 15 times 20. Well, forget that 0 at the end right now. And 15 times 2 is 30. Now put the 0 back on and I get 300. Well, now I've got an equation. Got the equal sign. I've got a variable. So my job is to isolate that variable. And that's exactly what step 2 says. Solve by isolating the variable. So I need to get the M by itself, which means I need to get rid of that 25. Isolate the variable by doing that inverse operation. The opposite of multiplying is dividing. Since it's an equation, I have to keep it equal, which means if I divide the left by 25, I have to divide the right by 25. When I do that, it creates that giant 1 that we want when we're multiplying or dividing. And that leaves me with M is equal to, well, I've got 300 divided by 25. I could divide, or think again, 25 is like quarters. How many quarters would you have to make $3? How many do you have to have? And that would be 12. So my missing variable is 12. Let's go ahead and look at that next one. Again, I already see that they are equal. That's why the equal sign is between them. So let's go ahead and use our cross products. D times 4, well, that's 4D. Equals, now do the other diagonal, 12 times 3. Well, that's 36. Again, I need to isolate that variable. I have to get rid of that 4. Inverse operation, right now it says 4 times D, which means opposite inverse operation would be to divide both sides. And when I divide both sides by 4, I get that giant 1. And I end up with D equals 36 divided by 4 is 9. So we're going to be working with some of these proportions today. So make sure that you do take notes, make sure you understand it. If not, bring those questions with you and we will go over some of these things in class. Have a good one and I will see you soon.